I welcome you all to our first session on the track Artificial Intelligence. Before moving on to the session, let me introduce to you all our speakers for this session, Dr. Jayaraj P B and Mr. Saimanoj A. Dr. Jayaraj P B is the Assistant Professor of CSE Department and Faculty in charge of AI Club NIT Calicut. His research interests include AI, high performance computing, and health informatics. He is author of a great deal of research studies published at national and international journals as well as conference proceedings. Mr. Sai Manoj is the Secretary of AI Club NIT Calicut. He is currently pursuing bachelor's degree in mechanical engineering at National Institute of Technology. His interests are AI and robotics and has worked on many projects. His COVID detection work, which uses AI, got published at CoConnect 20 conference held at VIT Vellore. On behalf of IEEE Malabar Subsection, I cordially welcome both of you to enlighten the participants about artificial intelligence.
Hello, am I audible?
Yes, sir.
Yeah. So my slide is also visible, right?
Yes.
Yeah. Good evening, all. Respected speakers of the day, organizers and students and parents. Once again, good evening. First, let me congratulate the organizers of the program for arranging such a nice program. Okay, so students, I think hope most all of you know the computing and some of the programming languages. So till today, most of you might be came up with rule-based programming languages like Python, C++, etc. Today, I will show you a new computing technique called AI, mainly machine learning in detail. Yeah, so AI, artificial intelligence. AI is the new electricity. People are calling it as new electricity. Electricity had once transformed countless industries. AI will bring equally big revolutions in industries like healthcare, manufacturing, and transportation. Now we will see some of the definitions of this AI and the history also. Yeah, what is artificial intelligence? It is the science and engineering of making intelligent machines, especially intelligent computer programs. It is related to similar task of using computers to understand human intelligence. But AI does not have to confine itself to methods that are biologically observable. This is defined. It is defined by John McCarthy, one of the eminent scientists in AI area. Some of the other definitions you will see, then later I'll explain things. Okay, the exciting new efforts to make computers think, the machines with minds in full and literal sense, defined by Hewland. Another definition by Rich and Knight, the study of how to make computers do things at which people are better. And Bellman defined AI as the automation of activities that we associate with human thinking, activities such as decision making, problem solving, and learning. Yeah, so AI is art of creating machines that perform functions that require intelligence when performed by people. Artificial intelligence is the ability to make computers or machine learning or machines to learn to solve problems that would otherwise require human effort. As you may be knowing, yeah, now in the digital, in the current era, more and more digital data is created. So when you take a photo, at least a new data is being created. So similarly, we have plenty of data with us. So we are living in a big data era. So if you can infer certain details from this data, which can be useful for the humankind, this will be a very good act. The advances in computing power have made it possible to analyze large amount of data quickly with consistency and accuracy. Now we will see history of AI. Yeah, so in 1943, McLeod and Pitts, they first invented neural network. And in 1951, Minsky, he built a neural net computer. Yeah, in 1956 is an important year in AI development. There was a conference held in the name called Dartmouth Conference, where 4 people met and they found this particular study of area called artificial intelligence. The name AI was coined in that particular conference only. In 1952 to 69, a Lisp programming language was found by McCarthy. Then in 80s, AI went into an industry. Okay, in 1986, again the neural network came for its second wave. Yeah, rediscovery of solutions leads to massive growth in neural network research. But then the main problem of this neural network was it was taking a lot of computational power. So the supporting platform, which uses only CPU, was not able to deliver this much computational power. So in 2007, GPUs were invented, and the CUDA parallel programming language, it's a framework basically, were also invented by NVIDIA. So succeedingly, 2014, Ian Goodfellow, he invented GAN network, which was one of the best invention in AI. In 2016, NVIDIA invented Pascal GPUs, which has unified memory in it. So utilizing which this larger neural network, we could able to run larger neural networks on these platforms. And 2017, another invention called transformers, etc., were invented. So all of them basically come under deep learning technique. So yeah, so I told you the birthplace of artificial intelligence, it happened in actually in a Dartmouth workshop. So 4 people, namely John McCarthy from Stanford, and Marvin Minsky from MIT, Herbert Simon from CMU, and Alan Newell from Carnegie Mellon University. They met each other, and they finally coined this field of study as, they named this study as artificial intelligence. Okay, so what are the main goals of AI? To make computers more useful by letting them take over dangerous or tedious tasks from a human. Yeah, that's way, because till today we were using rule-based computing, because while writing our program, you will have certain rules. So some if loop or something based on which we take some decision, right? But when the data which you handle grow large, this rule-based technique will not help you. Why? Because your loop, for loop or while loop, you will not be never-ending, and it will take days, months, and years, etc., to finish your program. So there, AI can help you a lot, provided if your platform can do a lot of execution at the same time. Yeah, so areas of AI. So some of the dependencies you can see here. Basically it's a searching technique. So we have machine learning, knowledge-based representation, NLP, computer vision, robotics, expert system, etc. So today I'll be explaining you more about machine learning. So I'll show you 2 case study application which we are using in healthcare. Yeah, basically I will be talking about healthcare application, and my counterpart, AI Club Secretary Manoj, will be explaining about self-driving cars, how AI is utilized in self-driving car. Okay, so yeah, we will go to the first case study. So the application of machine learning to drug discovery pipeline. Yeah, so drug discovery is an inventive process of developing a new drug which will be therapeutically active to a disease causing target molecule. Yeah, the main 2 terminologies appear here are target and ligand. Target is the key molecule that is specific to a disease condition. This is the disease causing molecule. Okay. Ligand is a small molecule which is coming and binding to this target tightly. Yeah, this binding actually results in a change of conformation, and we are getting a cure of disease. So these 2 terms, target and ligand, are important. So basically, by drug discovery deals with design of molecules that is complementary in charge and shape to the target to which it binds. So you can see the drug discovery pipeline. In a traditional drug discovery pipeline, it takes a lot of time. Why? Because it has to do a lot of wet lab experimentation. So the exploration space being large, it takes a lot of computational time and money. So that there, computers can help you a lot. The computer-aided drug discovery, you can see I'm applying computer here. So the modern computational machineries like data mining, machine learning, and artificial intelligence can help you a lot. It reduces the cost of wet lab. Yeah, that's why you can see here. So our aim is to develop a drug, right? For that purpose, we'll have to give a lot of lead molecules to the final wet lab experimentation. So there we are applying a technique called virtual screening. So it's a computational technique. Virtual screening is a computational technique used in drug discovery for evaluating large number of molecules to identify some lead molecules that can be optimized to get a drug molecule. You can see here. So this is 10 raised to 6, the larger search space. So this by using this virtual screening, the search space we are reducing into 10 raised to 2. Center from 10 raised to 7, we are reducing into 10 raised to 2. So here each molecule we are representing as a vector. Each vector comprised of 179 descriptors. A molecule, when you take a molecule, we are taking its molecular mass, pH value, electrostatic field, blood-brain barrier, etc. A lot of features we are deriving. So that usually there will be some pre-processing tools to actually to get this. And we'll have a lab final class called active or inactive. Yeah, say actually I have done an experimentation for tuberculosis, so Microbacterium TBs or target. So we in this cheminformatics area, so there are a lot of repositories in which they have uploaded the details of activity of certain molecules with this Microbacterium TB. So from that we are getting this much history. So utilizing this history, we can create model. Yeah, these models are called machine learning models. So here we use random forest, which is a kind of supervised learning technique. So finally, this model, when an unknown molecule comes, when we apply to this, it can classify it as active or inactive. So using computer, you can using the simulation, you can test these thing on 10 raised to 60 molecules, and finally you can give some 100 lead molecules to the wet lab experimentation. So this was the publication we produced for this based on this experimentation. So one more case study which I wanted to show you is a different one which uses images. Okay, so cervical cancer detection. In this case study, so cervical cancer is a major public health problem in India, predominantly affecting women of lower socioeconomic status. So due to the shortage of medical personnel to conduct effective screening, its mortality and morbidity is very high now. So the commonly used technique for screening the cervical cancer is pap smear test. But in countries like India, we are also following another test called visual inspection with acetic acid, VIA, visual inspection with acetic acid. So in that case, we will be taking a photo of this acetic acid after applying. We will be taking a photo of cervix, which is an organ, after applying this acetic acid. So the top one represents normal cervix. This is abnormal cervix, so which is cancerous. The first one is non-cancerous. So like this, we will have plenty of images. So say 10,000 of images we will be having. So some of the we basically have two groups. One is positive, another one is negative. So having this data with us. So the question is, if you can train a model, and if a new patient arrive, if your device which you are going to develop, if it can fetch and classify it as a cancerous patient or not. So such a kind of biomedical device we are deriving in NIT. So I just wanted to show you that. Okay. So with that, I'm completing my session. So thanks for inviting me for this program. Wish you all the best in your engineering career. So now I will transfer the control to Saimanoj, who is secretary of my AI club. Yeah, I forgot to tell you this. With a group of passionate students, we have formed a tech club called AI club at NIT Calicut. So our secretary will be talking to you. He will be primarily talking about self-driving car, how AI can be applied there. So I'm giving the control to him. Okay, thank you. So any questions you can ask at the end of the session. I'll be here.
Thank you, sir. Am I audible?
Just 1 second. I have. Yeah.
Hello. Can someone confirm whether I'm audible or not?
Yeah, you are audible, Manoj. Yeah, I think
Okay.
slide also visible.
Okay, fine. Good evening, everybody. As sir had already introduced me, I'm Saimanoj A. I'm Secretary of AI Club, NITC. So today I'm here to talk about self-driving cars AI. So I think many of you people are already heard of this name, self-driving cars. It's nothing but a car which can drive by itself. That's what we're going to discuss about today. So before going into self-driving cars, I just wanted to talk a few words about AI. Already, Jayaraj sir had explained few stuff about AI, what exactly AI is, and how is it different from traditional programming. But I just try to convey a different kind of uh, opinion about that. So there is a beautiful picture here, which we show to each and everyone who really want to get started with AI. Okay. So what this picture conveys is it is basically two block diagrams. One is about general programming. I'm not sure how many of you guys are aware of programming, but I heard that Kerala colleges teach programming in their 11th and 12th, which is not the case with our state. So if somebody is not aware of programming, it's nothing but it's a way of speaking to your computer. Okay. I'm speaking to you in English and you can speak to me in English because we both know English and we came to consensus on speaking English, right? So in the same way, we need to talk to computer in a specific manner. That's what programming is. In general programming paradigm, what we do is if you have a task, okay, so as human, someone called programmer will write a set of rules, which will be read by the computer, and then it'll read the question and the rules written by you, and it tries to compute the output. So that's how it works. So this pretty much all right for everyone as of now, but why exactly AI? Why do we need AI? Why not only general programming? Because general programming often it can fail, and often it can become hectic, I would say. Because let's say if you have a task to write a set of rules to recognize a human, okay? So if you're taking a pen and paper with you and start writing the rules for recognizing a human, what would you write? Maybe every human will have two eyes, two legs, and two hands, and so on and so forth, right? So you'll end up with a big list of rules. Still, at least you're able to write that. So you'll feed it to your computer, and now if some handicapped person comes in front of your computer, it will classify him as not human. So that's exactly the problem with this general programming is. So now you need to figure out each and every possibility that makes a human, right? So now it's growing much complex. So that's why, on the other hand, we have AI or machine learning models, which are smart enough. They operate in the same way like we humans operate, right? So let's just question how humans would tackle this task, classifying whether a photograph is of human or whether it's an animal or something else. So from the time of birth, we actually see humans roaming around yourself, and maybe your parents will point to someone and say that he's your uncle or he's your grandparents, something else. So eventually you'll build a structure of how actually a human looks in your mind. So, and as time progresses, you'll be getting better at this, and at a point of time you'll never make a mistake in recognizing a human, right? So that's exactly what machine learning models does. You'll feed it a lot of examples like a human photographs and non-human photographs, and machine learning model will eventually figure out the rules. So that's why AI is really smart, and everyone wants to somehow embed that in their work. Even as already introduced, I'm from mechanical engineering. So even in our field also, we're trying to in many fields, like in many sub areas of mechanical engineering also, we're trying to include this AI because it makes life easier. So that's about AI, and let's get to the topic of the day, autonomous driving AI. So why exactly should we try for autonomous driving AI, or why should you guys as an young engineers should pursue your career in this? So actually, autonomous driving can potentially, decrease the accident rate because it's an AI. It won't drink and drive. So there's a lot of road safety that you can ensure to the people. So, and also greater independence. If someone is handicapped, they no more need a person to accompany them while they're going out. Okay, so they can lead a life which they wanted to. They always wanted to. So yeah, and also one more thing is saving money. I know, like I'm not sure whether you guys know about this or not. Many of these autonomous cars cost really high, but on a longer run, you can save money because it's less accident prone. So now you won't often dash the dividers or garage or other cars, and there won't be any repairs to your car. So eventually you can save a lot of money from that. And another one is environmental gains, because a lot of these autonomous cars won't use any IC engines. Instead, they use electrical power as the main force. So there won't be use of any fossil fuels, and eventually can decrease the pollution and all. So these are the main four core advantages of having autonomous cars. There are a lot of many technical advantages also. I didn't include that because it might be out of scope for this section. Finally, you can see three pictures over here. I'm going to explain them what they are in few seconds. Let's first question how hard autonomous driving is to achieve. So as a human, if I randomly, ask someone of you to uh, tell how hard driving is. So many of you guys will say that it's not a big deal for us. We can ride a bike very easily. So as a human, you might feel that very easy, but as a computer, it won't. It struggles to learn how to drive. Okay. So because if you break down the driving scenario, you will know why it's really hard. So if let's say this is the I think this is the photograph that has been taken in Pune. So you have to keep an eye on this guy over there, and a lot of vehicles are moving, and there are poles, and you're going beside the divider. So you should be really careful. Rather, you should ensure that you won't hit that, and a lot of many things. You have to take a decision whether you need to steer right or left, or you need to apply brakes. A lot of things. So as a human, after training yourself for a week or so, uh, you know, you're really, you can master it in a week or so, okay? So, but that's not the case with AI because, yeah, as a computer, as I already told, it really struggles. Autonomous driving cars had got popular recently because of someone called Elon Musk. I'm not sure how many of you guys are familiar about him. But if you're active in Twitter, or if you're active in, actively following news, you will know that he's a greatest entrepreneur. And he had a company called Tesla, which mainly focuses on manufacturing autonomous driving cars. So in fact, he has a fleet of cars that are roaming around in US and getting better and better every day. So why am I telling all these things is there's a lot of career opportunities in this field, because there's a lot of research that's going on, and many people are still trying to figure out a really optimized way of driving with the help of computers, basically. So it's all about mimicking your own brain, because if you can see in these pictures, this is exactly what our brain also does. The middle picture, AI has drawn the red bounding boxes around all the dynamic vehicles, and also as you can, I think it can be understood by the intuition. Every different object is colored out with a different color by AI here. And this is a bit complex, but on a nutshell, what it conveys is, it tells us how far each object is from our camera. So if some object is really far from your camera, then that will be represented in a darker color. If it's not too far from your camera, that will be of brighter color. So these are the three basic tasks. That's why I've chosen to show you. This is not the end of the story. We have a lot of tasks that's going on after this. There is a long pipeline which enables the AI to take a decision whether you need to apply brakes or you need to steer forward. So yeah, people are really progressing in this area. They're trying to build decision modules so that decision modules are, they take these three inputs and they try to figure out whether.
We are running short of time. Can you please wind up fast?
Oh, sure. Sorry. That's what I would like to convey about. From this talk, I just want you guys to, pursue your career in this. So it's not really hard. Do check out in YouTube and all. That's it. Thank you for giving me the privilege of talking here.
Thank you. Thank you so much for gracing your important work and sharing your thoughts and opinions with us today. Thank you, sir.
Yeah, thank you.